Hey, Miss Park.
Hey, Adriana, how are you?
Good, how are you?
Good.
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 Um,
Are you
sorry, it
ready?
might take me a sec because I just got like I'm trying to do this on my phone and it's much different, so one
Oh,
sec.
okay. All right. Well, I'll just wait. You let me know when you're ready.
Okay, thank you. I
Not a
just
problem.
it took a sec longer than I anticipated.
I bet it is weird on your phone.
It is because you have to get all of these separate apps to do it with.
Wow. But it's kind of
Yeah.
cool to know that you can do it on your phone.
Yeah, it is good. You just have to have classroom and hangouts and all that fun stuff,
Yeah.
which I had neither of those things, so.
Okay. Well, you take your time. Let me know when you're ready.
Okay, I'm just trying to. I'm looking at the classwork that we have due, and I'm trying to see what I have and haven't done to see what I need help on.
Oh, okay.
Okay. Um, can we work on the um review? You're probably going to be disappointed because I'm like a little bit behind, but on the review worksheet 9.1 through 9.3.
Yeah. Let me make sure that I can upload. I'm not going to be disappointed, honey.
Oh well, actually, you already have this one pulled up. We can just work on this one. I'll figure the other one out.
Are you sure? Because I don't
Yeah.
mind going back to the other one. Math Lab is about whoever shows up, and you're the one that showed up, and you showed up first. So if
Okay.
you want me
I
to go back
mean,
and do that one, I am more than happy to do it. I just need to make sure that I can put it in PDF and pull it up.
okay, that would be great because I think I'm confused. I don't know at this point, which is probably bad.
Well, I was going to say, just to kind of give you an idea,
Mhm.
the first page of the test tomorrow
Mhm.
will look exactly like this page that's up right now.
Oh, okay.
So, and then the second and third page
Mhm.
of the test will look like that other review.
Mhm. Okay.
Uh, so what we could do is do a little combination of both. So if you'll give me a minute, I will make sure that the 9.1, 9.3 review, it was at the 9.1 to 9.3 review that you wanted to
Um.
work on, or was it the 9.1 through 9.4 review?
Um. Well, I think it was the 9.1 through 9.3, but the 9.1 through 9.4 is probably going to cover the same stuff.
Yes, and I was going to say, you know what? I might actually go back and update because I will take either one of those
Oh, thank goodness.
reviews, either one.
Okay, great. Then can we
So
just stick to the 9.1 through 9.3? Because I already have that out. I don't really know where the other one is.
the 9.1 to 9.3, you don't know where it is, and you know
No,
where the
I
9.1 to.
I would like the 9.1 through 9.3, please.
Okay, all right,
Thank you.
not a problem. I just need to upload it because
Yeah,
it's not on
sorry I'm
Google
making it
Drive.
a little complicated today.
No, you're fine. You're fine. It's not a big deal. I appreciate you showing up.
Mm-hmm. Well, if I didn't show up, I don't know how well I would be doing tomorrow, so. And we're getting close to the end of the semester, so.
I know, praise the Lord, eh?
Mm-hmm.
I'm uploading it just to make sure that I have it.
Yeah, that's fine.
And sometimes I make so many different versions of it. I'm hoping and praying that you and I have the same version.
Yeah,
That
that would be good.
I'm sorry.
I said that would be good if we had
It
the
would
same
be good,
version.
wouldn't it?
Yes, ma'am.
All right. So can we start here and then I'll go to the other one?
Yeah, that's fine.
Okay, cool.
Um,
Okay. Are you struggling at all with the unit circle? Should I skip those or go with those?
um, I mean, I
Or-
feel like I'm like 60% understanding. I think it's just more like the fact that it's a long, like kind of a long and different kind of tedious process.
Mhm.
That's why my brain is like, you don't get it. So maybe we could
Okay.
do like two of them just to
Absolutely. I just
ensure.
know that a lot of times you're constrained for time. So I want to make the best use of your time as possible.
Yeah, that would be great because I have a lot of papers to write today.
So that's why I was like, if we don't need to do those. So looking at the unit circle, because this is basically what you'll see tomorrow, but obviously they're going to pick different points. So what you would do on this tomorrow is we'll look at A, and
Mm-hmm.
you would tell me the degrees, the radians, and the coordinates for A. So what
Mm-hmm.
the degrees for A are, and I don't think I can
Um,
write on this little itty bitty table, but I'll try. But
okay.
you would just fill in right here
Uh-huh.
that, and then what are the radians?
Um, the radians would be pi over 6, right?
Yes, ma'am.
Okay.
And then the coordinates.
The coordinates are root 3 over 2 and 1 over 2.
Yep, perfect.
Yeah,
Okay,
I
so
understood how to do the table. I got that down.
okay, that's what I'm talking about. I didn't know if you wanted me to go through that piece or not. But
Oh no,
okay.
sorry. My bad. I didn't. My bad. Um.
Okay. All right. So the good news on the test tomorrow,
Mhm.
um, it has been changed so that all of like the radian measurements are together, all of the degree measurements are together, and then all of the inverses are together. Whereas on the review sheet, that is not the case.
Oh,
So
thank
you've got
goodness.
some regular ones, then you've got some inverses, then you've got some regular ones with that are measured in radians, and then regular functions that are measured in degrees.
Mhm.
So we're going to be kind of skipping around, but please know that the radians are grouped together, the degrees are grouped together, etc.
Okay, great. Thank you.
So on number 2, they're asking for the cosine, which is going to be the x coordinate um, of where of the ordered pair, the x coordinate of the ordered pair, excuse me, where, sorry about that.
It's all good.
Let me, so we're looking for the coordinate, the x coordinate, where 4 pi, where on the unit circle where 4 pi over 3 is. That's basically what that question is asking on number 2.
Mhm.
So tell me where 4 pi over 3 is, or can you tell me where 4 pi over 3 is? Like what quadrant?
Quadrant. Um. Quadrant 2, right? Maybe.
It's actually quadrant 3. It's down here. You probably would know that if you know you. And for me, when
Maybe.
I was doing these, I just rapidly went through and kind of filled out my unit circle. So it's actually also
Um.
240 degrees. If
Well, I
that
was
helps.
wrong.
If that helps.
Mhm.
Um,
On the when we're given this page, is it okay if tomorrow we go through and like label our unit circle? Is that cool?
yeah, that is absolutely cool.
Oh, thank
Absolutely,
goodness.
beyond a shadow of a doubt.
Because I'm gonna be
Even if
needing
you
that.
wanted to kind of roughly just get the degrees and the radians put in, and
Mhm.
then, and maybe put in one set of coordinates, because you probably don't want to take a whole lot of time to do it,
Right.
because, we've got an extra shortened day tomorrow because the release is 2:15, which
Yes,
I
ma'am.
think makes each class about 40 minutes. We've really shortened the test due to that.
Mhm.
Like, I think the first page has 6 problems on it. And
Wow.
then the second page has maybe, I don't know, 8 to 10. So
Mhm.
we'll give this a first section for
Mhm.
you guys, and then we'll take that up because there's one with no calculators and then one with calculators.
Oh, okay, great.
So we're going to divide it up and give you about 15 minutes and then another, 20 minutes for the other part kind of thing.
Okay.
Okay. So yes, absolutely. When I did this, I did it, but I don't know how quickly you can fill out the unit circle. So that was a long answer to a short question.
Okay.
But so I would kind of do maybe a rough sketch of it to get you through those.
Mhm.
All right. So that being said, we located our where this is on the unit circle. What are the coordinates for that piece? Do you remember?
Um, isn't it? It would be 1/2 negative 1/2 and negative root 3/2.
Yes, ma'am. That's it. Perfect. So what is the x coordinate of those two?
Negative 1/2.
So that is your answer. So when it asks cosine and either gives you a radian or a degree measurement,
Mhm.
or if it asks sine and a radian or degree measurement, it's basically looking for the x or the y
Okay.
at that particular point.
Um.
Okay.
Okay. Can we do um number? Well, are we gonna have those? Did you talk to Miss Stone and see if we can have the domain restriction worksheet?
She is not going to have hers have that domain restriction,
Mhm.
but I'm going to double check the test. And I don't think there's any on there that are going to cause you any stumbling without that. Does that make sense?
Okay. Mhm. It's just on the like. Can we just do number 3 and see if I
Yes.
understand? Because yesterday I was a little lost without the worksheet on this one,
Okay.
I
All right.
believe.
Let's talk about that one. Like, this is one where the domain restriction isn't going to cause you a problem in any way, shape, or form. So you obviously already know what you're doing because you ask about domain restrictions. So you're much further along than you give yourself credit for. But so working with the inverse, if you're given the coordinate, then obviously it's looking for either the degree or the radian measurement. And I'm happy with the degree. So basically here you're going to look for sine, the inverse of sine. So basically what they're asking you is, what is the y coordinate, or what is the degree measurement when the y coordinate is 1/2?
Okay.
Okay. So uh where is the y coordinate 1/2 on the unit circle?
See, the thing that I'm confused about is, isn't there a spot where, because I know the answer is 30 degrees from yesterday, but
Yes,
isn't there an answer where the y coordinate is 1/2 in quadrant 2?
yes,
So how do
ma'am.
you know
Good
which
job.
one it is?
I totally understand what you're saying now.
Mm-hmm.
So I would put it down, and basically, and if you put both answers down, I would actually be okay with that. If you were in a panic, I'm not going to be upset with that. But
Okay.
with this particular one, what I would look at is, since the sign is y, it's going to follow the y axis,
Mm-hmm.
okay? But
Right.
only in the part where x is positive. Well, and I guess that would actually happen, wouldn't it? So it would be um what would you say, 150? Yeah, 150 or 30.
Mm-hmm. But how do you know which one's the right answer specifically? Or are they both the right answer?
Just the first one that you come to, I guess, would be, and yes, so I understand exactly what you're saying.
Mm-hmm. Yeah, that's what I was confused on yesterday, but I didn't know if it was just me like not
Well, I will
paying
double check
attention.
with her in the morning and talk to her about the restrictions, the
Okay.
domain restrictions with regard to that, because I completely respect where you're coming from on that.
Okay. Good, thank you. And then can we do one with tangent? Because still not really getting that.
I will say this. What was interesting is I was just curious because, that's what happens to me. I just get curious when I do these things.
Mm-hmm.
And I put it in my calculator just to see what would happen. And it does return 1/2.
Oh, okay. Interesting. For either? For like
No,
150
yeah,
or
for the
30?
inverse.
Oh, okay.
I'm actually looking for something. I'm sorry because I was gonna put it. I was trying to download something so I could flash it up on the screen to kind of talk about it a little bit more with you.
Mm-hmm.
And of course, I can't find it. To go over that to help reinforce it, maybe. A little more complicated than I was hoping.
It's okay. It's all good.
Because I actually totally understand where. Ah,
Sounds like you found it.
yes, I did.
Okay.
So it follows the y axis. And I said what I said it wrong. It follows the y axis. And then I
Mm-hmm.
said where x is positive, and then I colored in where x was negative too.
Yeah, I noticed that, but I wasn't sure if like
Yes.
that was
Yeah. Well,
just
you know
me.
what, Adriana, you and I talk about this. Miss Sparks could hide her own Easter eggs. So
It's okay, me
all
too.
the help
I
she
get
can
it.
get. So these are all the places that x could be positive. So there's only one place where y is actually equal to 1/2. A
Mm-hmm.
positive 1/2 anyway.
Okay.
And so I decided that I would actually color it in pink this time.
But if y is a positive, but y is a positive 1/2 at 150 though.
Yes, but it can only be in this section, and 150 isn't over there. Because
Why?
I'm sorry,
Why can it only be in
that
that
is the
section?
domain restriction.
Oh, so that's just kind of how it works. Like, there isn't really
Yeah,
like.
what I was saying is that we already know, and I feel like you feel pretty confident in this, that sine is y. Do you struggle with that? Remembering that?
You know,
I loved Elijah's little thing. Why do you sin? I thought that was a
hmm
good way to remember it.
yeah, I think I'm okay with it,
Okay.
but I'm just kind of like uh
Well, I will tell
confused all the
you.
way around right now. So just pray
Okay.
for that test
Well,
tomorrow.
I will tell you that just like how you said you would jot down the unit circle.
Hmm.
Um, I actually write that at the top of my paper just so that it's just all I have to do is look up at it. You know what I mean? Like
Hmm.
cosine x, sine
Yeah,
y.
because the thing with me more is like I know it, but then whenever I get there for the test, I like second guess myself,
I understand.
and
I
yeah.
understand. And you know what? I don't struggle with dyslexia, but I can honestly say for whatever reason, trig can make me flip a lot of things. I don't know why that is, but it does.
Hmm.
So for me, the more I have written down, like the things that I know confidently, I just go ahead and write down some of those things at the top of my paper because I know them. But then when I start doing some of the problems, even I, get things transposed, perhaps.
Hmm.
Okay. So once again, let me explain. Let me go back to make sure that the sine follows the y axis. Okay.
Hmm.
So if it follows the y-axis, because sine has to do with y, so I always think of it traveling along the y-axis. But
Mhm.
the coordinates themselves can only appear where x is positive. Okay?
Mhm.
Now, let's think of another one. Cosine is x. So it follows the x-axis. Okay?
Mhm.
But only where the y is positive. So if you were dealing with a cosine one, like number 9,
Mhm.
okay? Where is cosine, or where is the x value root 2 over 2?
Um, 135 degrees.
Yes, negative root 2 over 2. Perfect. So over here. And it falls within that domain.
Okay.
So whatever axis it follows, like the x would obviously follow the x-axis and the y would obviously follow the y-axis. The domain restriction is the positive quadrants of the other coordinate.
Mhm.
Does that help or make it worse?
Um, it's one of those things that like I understand. It just doesn't really like logically make sense, but I get it. Like I'll be okay with it.
Okay.
Mhm.
And then with tangent, it's the exact same thing as sine. The domain restriction is.
Okay. And domain restrictions are only for inverse, right?
Yes, ma'am. Great question.
Do
Great
okay.
question. Yes.
Did you say yes? Oh,
Yes.
okay.
Yes. I'm sorry.
Okay, good. Oh no, it's all good. You just cut out for a sec, so I wasn't sure.
But that is a great question. But yes, they are only for the inverse.
Okay.
Okay, you want to do a few more regular ones, or are you good with those?
I just would like to do it like number 6
Number
would be
6.
great.
Okay, so
Mhm.
tan 30. So for number 6, what you're looking for is what are both of the coordinates at 30 degrees, which is actually this A one over here. What are both of the coordinates right here?
Oh, I'm supposed to tell you. Sorry.
Well,
Um,
I was just trying to help you work, a few things out, but that's okay. It's root 3 over 2. I'm just, kind of trying
oh
to
no,
make
it's all
you
good.
feel more confident of what you know, because I do know that you know this, because I think you've made 100 on your last 3 unit circle quizzes. So I know that you know that.
Mhm.
So now that you know both of the coordinates, tan is it's y over x is one way to think about it, but the other way to think about it is all of these wonderful things are this little triangle thing, and this hypotenuse is 1, is a radius of 1. So this is root 3 over 2, and this is 1/2.
Mhm.
So, no.
Someone else joined, by the way.
Oh, okay. So then we would have y over x, which is 1/2 over, or you could actually think, because tangent we know is opposite over hypotenuse, or opposite over adjacent. So that's where the y over x comes from, to kind of give you an idea. And so 1/2, so we have this right here, which then is 1/2 divided by √3 over 2, which is the equivalent of 1/2 times 2 over √3, which gives us 1 over √3, which then we rationalize our denominator. So then that's our answer.
Okay.
My thetas don't look very good in there.
It's okay.
But that's where all of that comes from. It's just all the same trigonometric functions all the way through.
Okay.
Are there any more on that page that you would like to do?
No, ma'am.
And let me just check out who joined us. Okay, Rachel joined us. Rachel, is there any more on that first page that you would like for me to do?
No.
Okay. You feeling pretty good about those?
Yeah.
Okay.
Maggie joined, by the way.
Oh, okay. Hey, Maggie.
Hey, girl.
We just went through page 1, and before I move on, because I know Adriana had some questions on some previous reviews that we had, and they're all very similar, so we're going to kind of go back and forth. But do you have any questions on this page? On page 1?
No, you're good.
You're good?
Yes.
Okay. All right. Is there, Rachel or Maggie, is there ones on these next 2 pages that you would like specifically for me to do before I move on to something else?
Can you do 16?
16?
Yeah.
I'd be
And
happy.
14.
16 and 14.
Yeah.
Okay.
Campbell also joined.
Okay. So number 14. Let me start there. Change 25 degrees to radians in terms of pi. So basically all you're doing here is taking 25 degrees and multiplying it by the proportion. And you want whatever you start with, you want that to be in the bottom part of the proportion. So what I want is 180 degrees to be in the bottom part of my proportion. Okay? So you're always going to be multiplying, like with number 13 or 14, you're always going to be multiplying by this proportion right here, but either in terms of pi over 180 or 180 over pi, determining what you're trying to end with. This sounds much like chemistry, doesn't it? Okay, so on this one, I want to simplify before I multiply, and I know that 5 goes into both of these. 5 goes into 25 5 times, and 5 goes into 180 36 times. So I'm going to end with 5 pi over 36. Because the reason why I want to make sure my degrees is in the bottom part of this is because I want my degrees to cancel out. So the answer to this one is 5 pi over 36. I believe the next one that was asked is number 16. Is that correct? So what I'm looking for there is tan. Oh, actually, it says find the measure of the indicated angle. So what I did is I concluded that I wanted to use tan because the two measurements that I'm given for angles are the opposite and adjacent. And I know that tangent is opposite over adjacent. So I picked tan. Okay. So that's tan theta equals opposite, which is 19, over adjacent. So I know then that reduces to 1/2. So I'm going to take the reciprocal of tan equals 1/2, and you just type that into your calculator, and it gives you some big long string of numbers, but we're going to reduce to the nearest degree, and I actually did the nearest tenth, and I did that. But that's calculator work. Do you understand? When you get something like this on the test, you kind of want to look at what measures of the sides that you're given so that you can then apply the best trigonometric function to that. Does that make sense?
Yes, ma'am.
Okay. And one's on the reviews that we're going to be going over also, because I've got another review I'm going to go through. But like number 17, pretty easy. We're given opposite. We're given the measure of both legs, and we're asked for tan. So this one was pretty easy because it's opposite, once again, over adjacent, which so there you go. Not too bad on that one. Is there another one on this page? Adriana, you'll talk to me. Did anybody type anything?
Well, I'm on my phone, so I can't really tell.
Oh, sorry. I'll go back.
Emily McGinnis said 15.
I don't think so.
Yeah.
Oh, 15. Okay. Cool. Thank you.
You're welcome.
Yeah, I should not be the typing and talking person.
Oh, okay. All right. That's good. I got you. Okay. I forgot you had told me that originally. I imagine.
Oh, no, it's all good.
It's difficult to see that. Okay. Number 15. I'm going to erase some of this stuff so I can give myself some room. No, I'm not. I'm going to scribble over it. Okay. Number 15. Suppose theta is an angle in quadrant 4 and cosine theta equals 10 over 11. Find cosecant theta. So let's draw ourselves a little picture. So we're looking at quadrant 4, which is going to be in this lower left or lower right quadrant. And it says that cosine is 10 over 11. And cosine is adjacent over hypotenuse. So that tells me that this side, I quit writing. Oops. This side is 11. And this side is 10. Okay? So that means to find cosecant, which is the reciprocal of sine, which is opposite over hypotenuse. So now what I'm going to be looking for is hypotenuse over opposite. So I've already got my hypotenuse, but I have to find the opposite. So how do I do that? I use the Pythagorean theorem, which says 10 squared plus b squared equals 11 squared. So that's 100 plus b squared equals 121. So b squared is 21. So this side right here is going to be negative square root of 21. And the reason why I say that is because it's this y measurement, okay, that opposite measurement. And because in this particular quadrant, my y is negative. So technically, my ordered pair for this is 10 negative root 21. So now what I have to do then is I would put my hypotenuse. Let me erase some of this. Over root 21, which I can't leave like that. I have to rationalize it. So my final answer is 11 times the square root of 21 over 21, and then it's negative. Any questions about that?
Emily said, what is opposite? Oh, okay. You good, Emily? Never mind. Okay.
Okay.
Never mind.
Okay. I just wanted to make sure that we can kind of talk about it. All of these, everything on the unit circle and everything in trigonometry thus far that we've dealt with has to do with right triangles. So everything kind of, even when we introduced it onto the coordinate plane, it's always a right triangle. So just all of these, when they play back to, like when you're putting it to the quadrant 4, just remember kind of to plot it on the unit circle and think about what quadrant it's in to determine where your coordinates are going to be positive and negative. And I was talking earlier in math lab about the fact that a lot of times there's a lot of moving parts in trigonometry. So at the very beginning, I will kind of write myself notes on when I'm taking a test, or even when I'm filling out these review sheets before I go over them with you guys. I'll actually write down those things that I know, including even good old SOHCAHTOA. I'll write that down and write down all of my reciprocal things like sine and cos. Like I would actually have this already written down somewhere on my paper just to remind myself of that, so that when a question is proposed, I have it written down. Because
this Sparks.
Yes.
Ooh, sorry, you can finish. This is for another problem.
Okay, I'm ready. I'm just trying to give helpful hints for you guys. But what's the next problem?
Number 20 would be great.
Okay, number 20. Okay. So, if angle B equals 3 pi over 5, give a positive angle that is coterminal with angle B. Oh, fun. I know the reason why y'all hate these is it all has to do with fractions.
You're not wrong.
I know. Okay, so 3 pi over 5 is just a measurement of on the unit circle, or a measurement given in radians of something within the unit circle. So what you're going to want to do to give a positive coterminal angle is you're going to want to add the equivalent. Like it was pretty easy on 19. You knew to just add or subtract in the case of 19, or to subtract 360. Well, the equivalent of a full unit circle in terms of radians is 2 pi. So what I need to do in order to give a positive coterminal angle is to add 2 pi to 3 pi over 5. Well, I can't just add 2 pi because in order to add fractions, I have to add something with a denominator of 5 because they have to have a common denominator. So how do I express 2 pi with a denominator 5? It would simply be 10 pi over 5 because 10 pi over 5 is the equivalent of 2 pi with 5 as the denominator. So you've got 13 pi over 5. Not too bad. Was that bad?
No, ma'am.
Okay. All right. Any more?
Emily said, can you say what coterminal angle is again?
Oh, yes, ma'am. Absolutely. Coterminal means, let's just say 120. This is probably not going to be exact. I'm really sorry, but it's somewhere around in here because it's, between 90 and 180. So this is like 120 degrees. Okay. Coterminal means I'm going to spin around one time. Okay. And so 120 and 360, that would be 480. So it's 480 is coterminal with 120. It just means it's actually the same line. You're just either spinning clockwise several directions or counterclockwise several directions. So negative means that you went the other way. You went clockwise because actually when you're working in the quadrant plane, you're working in a counterclockwise fashion, or yes, counterclockwise fashion. And when you're doing negative, you're doing clockwise. So coterminal means it's the exact same line every single time. You've just circled the globe a few times. Does that make sense?
What would the answer be for 21?
For 21?
Yes.
A positive angle that's coterminal with B. Because it's negative 520, I'm going to have to circle that globe a couple times.
Yeah.
So I would add a multiple of 360, which is 720 to that.
Okay, that's what I thought.
That would give me 200 degrees.
Okay.
Those are probably some of the most user-friendly ones on the test.
Yeah.
So, when you get to those, go, yay, Jesus.
I know, I do.
To me, the other ones that are pretty user-friendly are when you have to convert between degrees and radians because it's just that proportion thing. But yeah, I don't know. I don't think I mind fractions quite as bad as everybody else.
Emily said, so you add 2 pi because it's like doing the same things with degrees with 360.
It is. That's perfect. Y'all are geniuses.
So to find a negative, you would subtract 2 pi. Yes.
Yes, ma'am. You would. And basically the only tricky part to that would be, like if you were given something in terms of, say it was 4 pi over 3, obviously the 2 pi for that particular one would be 6 pi over 3. It's only converting that 2 pi to whatever the like denominator is. Does that make sense?
She said yes.
Okay, good. All right. Thank you for being my interpreter, Meg.
You're welcome.
Okay. Any other questions on this review from anybody? I'll do any one that you want.
Have y'all already gone over the first page? Yeah, can we do one from the first page?
I absolutely, I have gone over it, but I don't mind going over it again.
She said, can you do 7?
7, tan 90?
Yeah.
Okay, so what you're doing when they're, and what I talked about before, the good news for the test tomorrow is all of the cosine or all of the functions that are, just straight up functions asking for the coordinates. When they're radians, they'll be together. When they're degrees, and I think there's 2 in radian, 2 in degrees, and then there's 2 inverses. But they're all going to be grouped together. So like when it's tan 90, what you're looking for is where on the unit circle is the measurement 90 degrees. And that's going to be up here at the top. And at that point, what are the coordinates there? 0, 1. And tan is expressed y over x, or, so that's going to be 1 over 0, which is undefined. Make sense?
Miss Sparks,
Yes.
can you do number 23?
Number 23. I can do number 23. Is it, did that make sense for number 7, whoever wanted it?
Yeah. Emily McGinnis asked if you could do 6 too, but I don't know if you want to.
I can do 6. Let me do 23 real quick and then go back, if you don't mind. Because I was going to say I've already walked through number, I think whatever number it was, 6, with Adriana, and I know she had mentioned earlier that she has some papers to write, so I'm going to walk through this one. Use the given point on the terminal side of the angle theta to find the value of the trigonometric function indicated. So on this particular one, they're asking for cosine. And we know cosine to be by trigonometric. We've got on a good old SOHCAHTOA is going to be adjacent over hypotenuse, right? Okay, so what we're going to do here is we're just going to connect this, and we are given 4, and we're given -3. Okay, so we don't know our hypotenuse. So lovely old Pythagorean theorem. 16 plus 9 equals c squared. Yay, it's a pretty number. So our hypotenuse is 5. So adjacent is what value? Can anybody tell me? What would the adjacent value be? Is there any volunteers?
4.
Good job. And the hypotenuse value is?
5.
So there it is. Does that make sense?
Mm-hmm.
All right. I'm going to go back and do 7.
She wanted 6.
Oh, 6. And I meant 6. I just said 7. Sorry about that.
Wait, so what was the answer to 23?
4 over 5.
4
Okay,
over 5. Can you see it? I know you said you had to do it on your phone, so I
Yes,
just
ma'am.
making
Thank you.
sure. Okay, cool.
Yeah, I actually got to go, Miss Sparks. So thank you so much.
Okay, and I'll email you later about the other question that you had on the other review sheet.
Sounds good. Thank you.
Okay. Uh-huh. All right. So what you're looking for is where on the unit circle is 30 degrees and what are those coordinates, first of all. So on tan 30. So we know that the unit circle, on the unit circle, this A is 30 degrees. Can anybody tell me what the coordinates are there? Any volunteers?
3 over 2, or square root of 3 over 2, and then 1/2.
Yes, ma'am. Perfect.
Is quadrant 3 negative? It's positive, right?
Quadrant 3 is down here, and everything in it is negative. The X's and the Y's.
Okay.
Okay. All right. So on this one, on tan 30, what they're actually asking, and if you go back to good old trigonometry, what they're asking for here, we remember that tangent is opposite over adjacent. So opposite in this case is 1/2, or you can think of it in terms of y over x. Just kind of depends upon how you're thinking about it. But that's actually going to be opposite over adjacent. So now I have 1/2 over root 3 over 2. So that in terms is 1/2 divided by root 3 over 2, which is the equivalent of 1/2 times, just because you keep flip change, 2 over root 3. Simplify before you multiply. And then I end with 1 over root 3. I have to rationalize my denominator. Which then gives me root 3 over 3. So my answer for number 6 is root 3 over 3. Are there any other questions?
Can we do 22?
22. Okay. So if cosine theta equals -2 over 3 and theta in standard position has its terminal side in quadrant 3, find tan theta. Sometimes I feel like the wording to these makes them a little more scary than they actually are once you break them down. And I don't have a lot of space here. Can everybody see that okay? Okay, so for quadrant 3, that's going to be lower left. And cosine is adjacent over hypotenuse. So it's going to be -2. And this is 3. Okay. And I'm looking for tan, which is opposite over adjacent. So what am I missing? I'm missing adjacent. So how do I find that? The Pythagorean theorem. I'm going to do -2 squared plus b squared equals 3 squared. So that's going to be 4 plus, oops. Sometimes it just gets a mind of its own. Oops. So b squared equals 5. So that means this adjacent side is the square root of 5. I mean, the opposite side is square root of 5. So I've got the square root of 5, and it's negative because it's in the negative side, and both x and y are negative in the quadrant 3. So it's negative square root of 5 over -2. So the final answer, because a negative divided by a negative is a positive, the final answer is square root of 5 over 2. Does everybody see where I'm getting the sides and how I'm getting the negatives and positives?
I got it. Yep.
Okay. Is it making more sense, you guys? Because I know I heard the rumblings and I feel like people were confused. What, Maggie?
I think someone else said it. I don't know.
Oh, okay.
Why is it positive?
Because, good question, because it's in quadrant 3 and x and y, which in this case make up our adjacent and our opposite sides. So the adjacent side is -2, and the opposite side right here, which is this y measurement, is also negative because it's going down on the y-axis. It's in quadrant 3, which both x and y, in this case that make up the opposite and adjacent sides, are both negative. So a negative divided by a negative is a positive. Any other questions? Did that answer your question? Was that Campbell?
I think it was, but it says she left, so I don't know what she's doing.
Oh, okay. I don't know. I hope that answered her question.
I think it was, yeah. It made sense to me too.
Okay. All right. Does anybody else have one that you want me to do? 5 or 9? I popped back over to kind of see who all was here. Back up here. Okay. Let me erase some of this stuff over here because it's getting a little busy. 5 is cosecant of pi. All right. Cosecant is the reciprocal of sine. And it's asking for where pi is, which pi is right here. And so what is the ordered pair when you're here? Well, you've gone over to the left 1, so your x is -1 and your y is 0. And then I said that cosecant is the reciprocal of sine, and sine is adjacent over hypotenuse. So it's going to be hypotenuse over adjacent, which means a hypotenuse is always 1 on the unit circle, always. And adjacent in this case, or the sign, is 0. So that makes it undefined. Because sine is y. Does that make sense? And then number
So the
9
hypotenuse is always 1?
on the unit circle?
Uh-huh.
Yes, ma'am.
So for all of these questions right here, our hypotenuse will always be 1.
Yes, ma'am.
Okay. All right.
Just on these.
Just like on this page right here.
Yes, ma'am.
Okay. Yeah.
The hypotenuse, if you want to think about it like this, the reason why the hypotenuse is always 1, the unit circle is basically, this is the origin on the coordinate plane.
Yeah.
So this is just that first 4 squares of the coordinate plane kind of blown up. Like this is 1, 0. So you've gone over 1. Like, so if you were actually looking on this on a piece of graph paper,
Yeah.
that's what the unit circle is. So when you draw all these sweet little right triangles, this is always going to be 1, no matter what right triangle you draw.
Okay. That works.
Okay?
Yeah, that makes sense.
And that's why they call it the unit circle, because it's 1 unit, no matter where you are.
Okay.
I don't know if that helps or not.
Oh, yeah, it does.
Okay, cool.
I didn't know that.
There's a lot of little things to remember. Like I said, in trigonometry, there's a lot of moving parts, and y'all are doing fabulous. But, you know, that's why I said I write a lot of little notes to myself whenever I'm doing trig. All right. And then I believe somebody asked also, if I'm not mistaken, for number 9, I feel like. Is that correct?
Yeah, 9, and then JT asked for number 12 too after that.
Okay. All right. So number 9, they're asking for the
Sparks.
Yes.
Sorry, I have a question. So is like opposite equals y, and then adjacent equals x, and then the hypotenuse would equal 1?
Yes.
Okay.
Good job.
All right. Thank you.
No problem. That is another way to think of it. And then also up here, you know, I wrote it like that. Just as a note to myself. That's what I do as a note to myself. But yes, it is another way to think about it, because let's just, you know, draw this when you're thinking about it. When you put that cute little theta in that angle, which is really angle theta, whenever they're asking all of this good stuff, angle theta's coming out from the origin, if you will. And this is your hypotenuse. Opposite is going to be over here. And adjacent is going to be here. So your adjacent is your x-axis, and your opposite is your y-axis. So thereby sine, which is opposite over hypotenuse, and cosine, which is adjacent over hypotenuse.
Yeah. Okay, thank you. It's just so confusing because there's like so many different names for the same thing, so I just get so confused. But
I understand perfectly. And that's, you know, I do. There, like I say, it's a ton of moving parts. So I think one of the reasons is not really to add the confusion, but just to connect everything. And everybody likes to think about it differently. You know, I believe like last week, we introduced, you know, like y over x and y over r and all of that stuff. But if it just seems better to keep it with adjacent, opposite, and hypotenuse, then stay with that, because that way you're kind of keeping the same flow of things all the way through. I hope that helps.
Yeah, it does. Thank you.
Not a problem. And stop me anywhere you guys need, you know, clarification, or if you think I can help in some way. Okay. All right. 9 and then 12. So we're doing the inverse of cosine here. So what we're looking for is where does cosine, or in this case, because the hypotenuse is always 1, you can kind of think of it, if you're thinking about cosine, you're thinking of adjacent over hypotenuse. And since the hypotenuse is always 1, then you're just looking for adjacent. And the adjacent one is along the x-axis. So where is the x coordinate a negative square root of 2 over 2? On the unit circle. Where does that happen? Can anybody tell me where is this negative square root of 2 over 2?
135.
135. Oh, and it locked up on me. I hate to do this to you guys, but I'm going to have to reload the review. Sometimes Cammie does a sweet thing and she locks up on me. So 135 degrees. Because over here, the coordinates are negative root 2 over 2 and root 2 over 2. Does that make sense? And then somebody asks for 12. Oh, this one's a fun one. All right. You're looking for where tangent is negative root 3 over 3. Well, first of all, you know that there's not a coordinate that way, but can anybody tell me what tan is? Tangent is what? What two sides?
Is it sine over cosine?
It is sine over cosine. It's sine over cosine, or y over x, or opposite over adjacent. However you think about it, that is what it is. So what you're looking for on the unit circle is what two coordinates are gonna end up giving you a negative or the opposite of root 3 over 3. And then you also have to think about your domain restrictions. So this one follows the y-axis on the positive side of x. So what you have to think of is the coordinates that are going to end that way. So what you really want to do is think about something that's going to have the radical in the denominator. That would be the best way to think of it, because how I know that is whenever I see a radical in the numerator, I know there's probably a good chance that I'm going to have to rationalize that denominator. I wish there was a clearer way of explaining it. The other, so the only way that I can think of that, since it is sine over cosine, then I know my x value is going to have the root in it of root 3. And the only place that that occurs is right here. Oh, it locked up again. Technology. And I say that because this is going to give me this. Which turns out keep, flip, multiply. Simplify before you multiply. And that gives me 1 over the square root of 3. And then I rationalize my denominator, which that's what I was talking about. You're almost thinking ahead as to what is going to give me, my bad, what is going to give me a radical in the numerator. And you might, the only other one that has a root 3 in the coordinate pair at all, if you were to pick the other one, you're going to end up with root 3 over 1, which is root 3. So there's only 2 coordinates that is a possibility. And so because this is the opposite, you're going to do negative 30. Because it's the opposite of root 3 over 3.
Is there any other way to write it besides negative 30? Like, could it be like 330? Is that wrong?
I see exactly what you're saying, and I agree with you that it could be 330. I feel like that is an acceptable answer. And I know I sound somewhat questioning about that. But I know that I would accept it on mine because of that, because you've got a negative and a positive coordinate. So why wouldn't it be that? And it falls within the domain restrictions. She only had negative 30 written down on her answer key. I had both written down on my answer key. So, because I feel like you're asking for Miss Stone, you're Miss Stone's class, right?
Yes.
Okay. And is this Alyssa? Is that right? Am I recognizing the voice?
This is Emily.
Oh, Emily, I'm so sorry.
It's okay.
I didn't switch over to see who was talking. So let me, do you care if I email you specifically about that?
Yeah, that's fine.
All right. I apologize for not knowing right off the bat, because it does fall,
You're fine.
It does fall within the domain restrictions, and one of the coordinate pairs is negative. So I can totally respect where you're coming from.
All right, thanks.
Not a problem.
Is there going to be one like number 18 on the test?
because you all are in math lab, I'm going to give you the good news. There will be one on the test like that, but it is multiple guess.
Okay.
But I am happy to work it with you.
Yeah, can you? I don't really get that one.
Okay, absolutely. Okay, so if angle B in standard position has its terminal side through the point with coordinates -2, 3, so that means it's going to be in quadrant 2 because my x is negative and my y is positive. What is secant B? And secant is the reciprocal of cosine. So what I'm looking for in cosine is adjacent over hypotenuse. So I'm going to be looking for hypotenuse over adjacent. So what I'm missing is hypotenuse. So I'm going to take -2, oops, my bad, squared plus 3 squared equals c squared, was be 4 plus 9 equals c squared. And so c squared is 13. So the hypotenuse here is the square root of 13. And so I'm going to have the square root of 13 over -2.
Okay. Got it.
Okay.
It's just the way they ask it. I get like so confused at what they like want.
I understand perfectly. I totally get where you're coming from. So if you just break it down, and I'm trying to remember. I'm trying to remember on the test specifically how it's asked. So give me just a minute and I will double check to give you an idea of exactly how it's asked. So bear with me.
Okay.
1 second. It is going to be asked in such a way where you're going to be given a point and it's going to say something, given a point on the terminal side, find the trigonometric function indicated. So then it's basically going to have this terminology in it and it's going to give coordinates. So it's going to say use the given point on the terminal side of angle theta. So instead of having like if angle B, it's just going to say angle theta. Give the trigonometric function. And then it's kind of like the same instruction for two problems. So you'll be given like, say, just this would be written secant theta and then -2, 3. And then the overall instructions would say that its terminal side is that. Does that make sense? Or is that more confusing?
No, that makes more sense.
Okay. So it'll be given like that. So you'll just say secant theta and -2, 3. And then you'll work with those particular.
Okay.
So it would have been easier for you had it been worded that way? Is that what I'm understanding?
Yeah, like if it just said fine, like not like the angle B kind of confused me.
Okay. Because we're kind of using theta sometimes and this sometimes, and I got you. Okay. The good news for that part is it could be asked all kinds of different ways on a on a standardized test. So being exposed to all of these different ways is probably good. But hopefully breaking it down and showing you how they're similar or how it can be worded and yet it means the same thing. And going through different various examples, hopefully it's making more sense. Are there any questions about this review or any other assignments that have been given for chapter 4? Okay.
So
I don't have any. This is Walker, by the way.
Who is it?
It's Walker.
Hey, Walker. I
Thanks,
just
Mark.
saw that somebody asked for 13.
Mm-hmm.
So,
Yeah.
all right, let me do 13 real quick. But Walker, you don't have any more?
Probably not. I might be leaving soon. Gotta go. But thank you so much for Sparks.
Oh, not a problem. See you tomorrow in class.
See ya.
Okay, so number 13, changing 11 pi over 9 to radian or to degrees. So it's given in radians, so you'll just use the proportion. We use pretty much the same proportion going from radians to degrees to radians. It just depends upon which piece goes on the bottom. So whatever you're trying to get rid of, you want on the bottom of the proportion. So here we're trying to get rid of the pi symbol or the radian measurement. So I would do 11 pi over 9 times, pi would go on the bottom because that's what I'm trying to get rid of. And 180 degrees would go on the top because that's what I'm trying to convert to. So my pi's cancel and 9 goes into 180 20 times. And then 20 times 111 is 220 degrees, or 220. So my answer is 220. Any other questions?
Can you do 16?
Yes, I can. And I do know that the questions are worded a little differently. The good news is y'all will have already been exposed to some of this is good old pre-calc wording. Yay! So 16 was the question?
Yeah.
Okay.
Mm-hmm.
All right. So for me, when I looked at this, I'm trying to find the measure of the angle indicated. So then what I'm going to look at is what trigonometric function do I know that I can work with the measures of the sides that are given. And I can look at it and see, yes, absolutely. It's tan because I'm given both the measurements of adjacent and opposite. And that is tan because tan is opposite over adjacent. So the opposite in this case is 19 and the adjacent is 38, which reduces to 1/2. So I can find the inverse of tan, and that will give me, and when I use my calculator to do that, and then that will give me the measurement, and it's 26.6.
But how do you think of that? I would have never thought to do that.
Okay. That's a really good question. So when you're looking at a triangle, and there's something missing on it, first of all, the very first thing you want to do is make sure that's the right triangle because these particular trigonometric functions don't work unless it's a right triangle. That's why this has all been called right triangle trigonometry. And I say all of this because right after we take this test, we're going to introduce you to non-right triangle trigonometry. So what you're going to want to do is when you have a missing angle and you see that pretty little red square, you're going to know that you can use your regular SOHCAHTOA stuff. So then you're just going to want to default to that type of thinking, and figure out what legs have they given me? Have they given me 2 legs? Have they given me a hypotenuse or so? Then you're just going to try to trigger that style of thinking. I don't know if that helps or doesn't help.
Okay, yeah.
Just training your brain to think that way. When there's a missing angle, I'm going to look for an inverse.
Okay. So the inverse of tan is 1/2?
Well, okay, so what you would do then is you would type this into your calculator, second function tan inverse, and then you could type in, it's going to open the parentheses. You could do 1 divided by 2, or you could put 0.5, whatever you want to do. And then once you hit enter, it should feed back to you, spit back to you a string 26.6 and a string of other numbers, and then you round.
Okay. Okay, I got it.
Okay. And the other good news, besides one part, for those of you who weren't here earlier, the test is going to be given in 2 parts because our day is shortened a good bit.
So we're not taking the whole thing tomorrow?
Well, you'll be taking the whole thing, but what we're going to do is hand out the first page, or the first part, which is going to be the multiple choice.
Okay.
And that will be very much like what y'all have done on pages 2 and 3 on the review. And this should take you about 15 minutes because there's 10 problems on that, and you can use your calculators. Then you'll put your calculators away, and then you'll do the page 1, the unit circle part with no calculators. And there is a total of 6 questions there. Number 1 being A, B, C, and D, exactly as it is on this particular review. The other part of the test is very much like the 9.1 through 9.3 and 9.1 through 9.3 review that we had. I believe it was last Friday and Monday. So it'll be like that to kind of familiarize you with the style of test. But it is honestly, you work through this review, and you guys, honestly, just if you can do these, you might even want to try to maybe put your answer key aside later and do a few more and see if you could just start fresh and start from scratch. But you guys should do great on this. Y'all have asked great questions and done very well in the review. Are there any other questions though?
Sorry, you probably already answered this, but if I just do this review packet, for the most part, I should be good on the test if I just make sure I completely understand this packet.
Absolutely. Because I feel honestly that the test is so much easier than the review packet.
Okay, yay. Perfect. Thank you.
And we did that kind of intentionally because we know that y'all are going to have a limited time tomorrow, and so we thought if we just really stretched your brains on all of the reviews that we've given you, that you would be good for the test. And I saw Andrew Crawford said a long time ago that he's going to fail this test, and you are not going to fail the test, buddy. You're going to do great. I know it. But yes, this review should help you wonderfully. If you can do it, you will be able to do this test tomorrow. But please ask me any questions that you have. Anything else? Anything else I can go over for you guys? Even on other homeworks. If there's not anything else, I guess we'll call it a day. Are you good, Emily? Are you good, Rachel?
Yes, I'm good. Thank you.
Not a problem. Not a problem. If you, bye, Walker. If you have any other questions, please email me or Miss Stone. Okay?
All right, thank you.
No problem. Y'all have a blessed day. You're welcome, Emily.